Good evening, everyone. My name is Philip O'Connell and I'm the Executive Director at the Westmead Institute for Medical Research. And I'd like to welcome you all to the Institute's Meet the Researcher seminar. This evening, our focus is on mental health, and we'll be hearing from two of Australia's leading researchers in this space, Professor Anthony Harris and Associate Professor Mayuresh Korgaonkar, as well as PhD candidate Taylor Braund. Before we get underway, I'd like to begin by acknowledging the traditional custodians of country throughout Australia. In the case of Wimmera, it is on the land of the Darug people, and I would like to pay our respects to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. This evening, the team will share with you the work they are doing to transform the way we understand, treat, and prevent depression in Australia and around the world. Wimmera's Brain Dynamics Centre is dedicated to investigating a broad range of neurological conditions, including anxiety disorders, ADHD, schizophrenia, and depression. This evening, the focus is on depression. This is particularly relevant in this time of COVID, and we know that rates of diagnosed mental illness are on the rise. In Australia, it is estimated that 1 in 5 Australians will experience a mental health issue in any 1 year, and that 1 in 2 Australians will experience a mental health issue during their lifetime. We know too that approximately 7 Australians die every day as a result of suicide. On average, 5 of these 7 are men. Mental illness is particularly relevant among young Australians, with 1 in 4 Australians aged 16 to 24 reportedly living with a mental illness, and 1 in 3 experiencing moderate to high levels of psychological distress. The World Health Organization predicts that depression will be the #1 health concern in developed and developing countries by 2030. Factoring in its impact on the economy, social fabric, mortality and morbidity, we know that depression accounts for the 3rd highest burden of disease in Australia. There's no doubt that mental illness is an issue we simply must address, and we must do this with rigorous, evidence-based medical research. By way of introduction this evening, I'd like to provide you with some background about our speakers. Professor Anthony Harris is a consultant psychiatrist with a special interest in early intervention in psychosis and psychotic disorders. He is co-chair of the Sydney Medical School's Neuroscience and Mental Health Research Team. Professor Harris's primary clinical and research interests includes psychophysiology, neuroimaging, and treatment of first episode psychosis, schizophrenia, and major depression. He has made significant contributions to the understanding of functional neurological changes associated with psychotic illness and led to advances in psychosocial treatment of schizophrenia. Professor Harris has a special interest in medical education. He is chair of the One Door Mental Health and chair of its Research Trust Fund. Associate Professor Mayuresh Korgaonkar, it's got a slightly different twist. He actually holds master's and doctoral degrees in biomedical engineering. And he leads the scientific direction of Wimmera's Brain Dynamics Centre. He is a Career Development Research Fellow of the NHMRC and a Senior Research Fellow at Sydney Medical School. As mentioned earlier, Taylor Braund is a PhD candidate at the University of Sydney and is supported by a New South Wales Health PhD scholarship and an accelerator grant. He's also a research associate at Total Brain. Before we get underway, I do want to let you know about your microphones and videos and to let you know that they will not be active during the presentation. This means you will not be visible to others on the Zoom call and will be unable to ask questions through your mic. We expect our seminar to go for approximately 1 hour tonight, with some time for Professor Harris and Mayuresh and Taylor to address a selection of questions submitted ahead of this evening's session. I would now like to hand over to Professor Harris and thank you again for joining us this evening. Anthony, it's over to you.
Thanks very much, Phil. And welcome everybody to this, this webinar, Great Depression. And thank you very much to Laura Robinson for organising this. At the beginning, I'd like to acknowledge people with a lived experience of mental illness, as the numbers that Professor O'Connell with Phil went through. Mental illness is a real scourge for this country and is something which we at the Brain Dynamics Centre are certainly trying to work towards helping with. As Phil mentioned, the Brain Dynamics Centre is the unit of the Westmead Institute for Medical Research, which looks at mental illness and neuroscience. We have a broad range of interests in this particular area, and during the presentation tonight, we'll be going over the way that we go about our research and what we want to get out of it, what we want to understand. So some of the illnesses that we look at Brain Dynamics Centre or BDC, anxiety disorders, particularly post-traumatic stress disorder. And Richard Bryant, who's not with us tonight, is a leading expert in that particular area. We also look at bipolar disorder as one of the mood disorders, which Mayuresh will be touching on during tonight's presentation. Eating disorders, an area which is very important for many young people, people that I look after, is also an area that we look at, and trying to understand why people get so worried and addicted to their food. Schizophrenia or psychosis is an area which is of particular interest to me, trying to understand how this illness might come in and distort the reality that people are experiencing. We have a number of research projects that are looking at that, trying to understand how the brain reacts to and forms these particular ideas. ADHD or attention deficit hyperactivity disorder is part of what we look at, and depression is a very important part. We've had several very large research projects about depression. Now, mental illness, mental health, and the normal brain development that underpins our mental health is something that we really haven't known a huge amount about, because it's only been relatively recently that we've had the information, we've had the means, we've had the techniques to actually investigate how people think, how people imagine, how people experience their emotions in a way which we can measure in the brain. And the Brain Dynamics Centre has been one of the leading institutions in this country at developing ideas about how the normality of brain function changes with illness. But coming back to depression, which is the theme that we're looking at tonight, what do we know about depression? Well, over 1 million people in Australia are experiencing depression of one sort or other today. That's an extraordinary number of people. And we'll be hearing from somebody who has experienced this in a little while. That translates to 1 in 7 of us experiencing depression at some time in our lives. And understanding the effect of that on people is very important. So a tremendously high burden of illness results from mental illness in general, but depression in particular, because it's such a common disorder. Unfortunately, over 2,500 people die in Australia every year from suicide. And as Phil said in his introduction, most of those are men, and most of those are actually young men under the age of 45. And this is the commonest reason for young men to die in this country. It's something that we really have to do something about. And most of those young men are depressed. Now, at this stage, I'm just going to invite Shukri Ahmed to have a small discussion with us. Shukri is a person who has had depression and has been involved in some of our research. And he's come forward as somebody who just wants to talk a little bit about what it's been like for him. And so, Shukri, what sort of symptoms did you notice when you first developed depression? What did you notice?
First of all, I think I was confused. Didn't know what I really wanted. Didn't know what I was doing. Didn't know where I was going. I was feeling like there's a failure in my life. Feeling like lost. Like failed myself, failed the family, I meant to say. And just confused. And didn't know what was happening. And quite frankly, don't know for how long and how long it's been since very first time probably I started to have the symptoms. It's just that 2014, I think I lost that lot. Then I started looking for help.
And what sort of help were you able to get? What sort of treatment did you have, and what has worked for you, in whether fully or only partially?
Well, at first, when I didn't know what I wanted, started from the employers, asking them for things to help me, how to actually be more productive, get more word at work, sort of, like delivering what I was getting paid for. That was one part, but then start see the doctors, the medical side, and I was Googling things, where to talk to someone and to see, was I the only one there out there, or was other people, and they're searching for the answers that I didn't know. But then I came across to some people who actually, they happen to be at like-minded at Seven Hills and run through REMISSION, United Church sort of thing. Then from there on, I think what I started really started getting the help that I have come across through so many courses through Western Recovery College, and also coming across through with Kathy Kearney down there at Cumberland Hospital, then where I meet Rita as well. And then I have come across for help to you guys there. And I've done the MRI. And
thank you for that.
And from there on, then I have seen psychologists, which I'm still seeing today, and psychiatrists. Then I've been put on medication.
How many different medications do you think you've been on?
The most ones that I actually have been, has been metazapine or Avanza. And then the other one that I've recently taken as well, it's Valdoxan.
Yeah. Okay. And what sort of effect do you think this has had on your life?
I think it was devastating because first you're looking for something that you don't know what you're looking for. Like I felt like I was felt in space, like, and then when I came across to these groups and these organizations that, and then, so I said earlier, I have done lots of, for nearly 2 years in a row, so from 2018 and onwards, even now, I'm still doing courses about mental health, that it made me like a different person, a little bit knowing a bit more about, and secondly, that I wasn't alone. There is a lot of people out there like me. And in some ways, I think there is help if you're only looking for it, but you gotta look, because it doesn't come at your door knocking telling you. So now what I think is, what is working for me is really, I'm taking care of myself with meditating, sort of mindfulness, and with medication, trying to connect with the nature and keep walking daily, and it's kind of, it's working for me. I'm not saying that I'm over it. I'm still, or I think perhaps I'll be cured, because I think depression is just the level of it, because everybody out there could be depressed in this kind of, especially this kind of environment that we live. But I think the important thing is, if you can manage how to live with it and how to cope with it and dealing with it, I think that's the best key is. And I have that be maybe because of medication or my cure, one day I'll be depression free, but it's only time will tell.
Thanks, Shukri. Thanks very much for that.
My
Thank you. So, I mean, I think if we look at some of the signs and symptoms of depression that Shukri was talking about that feeling sad and losing interest, but also feeling quite lost, feeling cut off from people, feeling that as if he was bad, he was worthless, and feeling sort of isolated, as if he was the only one with this terrible problem. They are some of the real symptoms and signs of depression that are both undermining for people with the disorder. The lack of energy, the lack of being able to get up and go, the lack of being able to concentrate at work. All of these things are really undermining for people. Other signs and symptoms of depression include weight loss. Sometimes people can get a real carbohydrate craving. That's part of something like bipolar disorder or some atypical depressions, but often weight loss, often sleep disturbance of one sort or another, feeling restless, feeling out of place, not being able to think, not having energy, and at its worst, suicidal thoughts and acts. So it's an illness which undermines and which also can be very chronic and disabling. What causes it? Well, we are trying to think about that, trying to research some of that. Certainly genetics is very important, and about 40% of people who have depression in their family that can go on and be part of the cause of depression. That's a very complex polygenetic inheritance that we're talking about, but it's part of the causes. Alcohol, drug abuse is there for some people. This is medical conditions. Sometimes the medications that people are taking for medical conditions can contribute to depression. And past trauma, whether early in life or in accidents or in problems, in assaults, can also contribute to depression. So you can see that depression itself has got many causes, and because it's got many causes, it probably is going to have many routes and many treatments to help people get over it. And this leads to great confusion about what might be best for any one person. Now, I'm going to, at this stage, pause and hand over to Taylor Braund, who one of my PhD students, who's done a fantastic work in his PhD on depression, and ask him to take over the presentation at this particular stage for a period of time. Thanks, Taylor.
Thank you, Anthony. And thank you, Shukri, for sharing your lived experience with us tonight. And thank you, everyone, for joining us, allowing me to present some recent research we've been working on at the Westmead Institute for Medical Research and here at the Brain Dynamics Centre. So I'll be talking to you a bit about the findings from the ICE-BLOOD-D study that we ran here. But first, I just want to explain the motivation behind the ICE-BLOOD-D study and why it was started in the first place. So depression is highly prevalent. It affects around 4 to 7% of the population, depending on where you live. And this equates to over 1 million people in Australia and 300 million people worldwide. While a range of treatments exist for depression, the first line of treatment for those with severe depression are antidepressants, such as selective serotonin reuptake inhibitors, or SSRIs. So SSRIs can be effective at alleviating symptoms of depression, but for many, at least in their first instance, as we heard from Shukri, they won't. Only half of people treated with antidepressants will respond on their first try, and only a third will remit. This is due in part to antidepressants being selected on this trial and error basis. We don't really know who's going to work, which treatments are going to work for who. And so this was the motivation behind the ICE-BLOOD-D study, or the international study to predict optimized treatments in depression. So the iSpot-D study is currently one of the largest biomarker studies in depression and recruited over 1,800 people with depression and 336 controls at 22 sites over 5 countries. And one of the sites was based here in the Brain Dynamics Center. So this iSpot-D study was specifically designed to identify clinical and biological markers that could predict treatment outcome to the 3 most commonly prescribed antidepressants. Secondary outcomes of this study were to identify predictors of treatment outcome in depression subtypes, including anxious depression, which was the focus of my PhD. And what makes the iSpot-D study so unique is the breadth of measures that were collected that you can see here. These include clinical and cognitive assessments, physiological measures such as brain activity, heart rate, sweat response. We have brain imaging through MRI and genetics. And using these measures together allows us to build an overall profile of what depression and its subtypes look like. We can also test whether any of these measures at baseline are able to predict whether someone will or won't respond to a certain medication after an 8-week course of treatment. So I was specifically interested in people with both depression and anxiety during my PhD research. And this is because anxiety disorders and high levels of anxiety are present in about half of the people with major depressive disorder. These anxious forms of depression have been associated with more severe clinical profiles and a poor response to antidepressant treatments. And one way to assess how depression and anxiety is impacting someone is by testing their cognitive functioning. So cognitive functioning refers to a range of mental abilities, such as learning, thinking, and reasoning, that can be organized into these specific domains. And in iSpot-D, participants completed a large cognitive assessment battery, which gauged functioning across these broad range of domains. And we expected that people with anxious depression would have poorer cognitive functioning compared to people with non-anxious depression. This poorer cognitive functioning also reflects issues with underlying neurobiological functioning that might impact one's ability to benefit as strongly from antidepressants. So we also expected that the poor cognitive functioning, specifically in people with anxious depression, would result in a poor response to antidepressant treatments. And we did find this relationship in the cognitive functioning domain known as verbal memory. So to give you an idea of what verbal memory is, the verbal memory test involves giving participants a list of 12 words to remember. After being provided another list of words to remember, which we call distractor words, we then ask the participants to recall the original list of words into a microphone. And verbal memory relies on processing in frontal and temporal areas of the brain. So this graph shows what the verbal memory findings look like. On the graph, the bottom axis shows the participants' average verbal memory performance, and on the side axis shows the participants' probability of achieving successful treatment outcome. And for people with non-anxious depression, the light blue dotted line, the probability of successful treatment outcome doesn't change based on their verbal memory performance. You can see it's fairly flat. But for people with anxious depression, shown in the dark blue solid line, as your verbal memory performance gets worse, so does your probability of achieving successful treatment outcome. And conversely, as your verbal memory performance increases, so does your probability of successful treatment outcome. So we found this trend was consistent across both clinician and self-rated measures of treatment outcome, as well as different characterizations of symptom reduction, such as remission, which we characterize as the complete absence of depressive symptoms, and response, which is the reduction of depressive symptoms by at least 50%. And together, these findings suggest that poor verbal memory functioning in people with anxious depression specifically is associated with poor response to antidepressant treatments. So another way of looking at comorbid depression and anxiety is through personality, and specifically the personality trait neuroticism, which is one of the 5 main personality traits that you can see here. So neuroticism is characterized as the tendency to experience negative emotions, such as depression and anxiety, and experience emotional instability. So in people with major depressive disorder, neuroticism represents one of the most reliable and replicated markers of poorer treatment outcome. While neuroticism is considered a relatively stable trait once you reach adulthood, studies have also shown that antidepressants can decrease people's level of neuroticism. So based on these previous findings, we wanted to see whether we could identify a neural signature of neuroticism using cutting-edge brain imaging and network-based statistics. We also wanted to see whether this signature changed after antidepressant treatment in line with behavioural measures. So we analysed data from a subset of the iSpot-D sample who completed functional MRIs at Westmead Hospital at baseline and then 8 weeks after treatment. And so we were able to identify this neural, or what we call a connectomic signature of neuroticism, which was highly interconnected and spread across the 8 subnetworks identified in the brain. So the strongest connections were seen within and between the salience network, which is involved in detecting and filtering important information, the executive control network, which is involved in the integration of sensory and memory information, and the regulation of cognition and behavior, and the somatomotor network, which is involved in sensation and movement. So once we identified this network, we then wanted to check to see whether it changed after 8 weeks of antidepressant treatment. And we saw that in line with predictions, the average network connectivity strength decreased after antidepressant treatment. And we also saw that there was no change in healthy controls connectivity from baseline to week 8. So taken together, these results suggest that there's at least a neural basis for neuroticism, and that this signature follows predictable patterns in line with behavioural measures of neuroticism in people with major depressive disorder. So bringing it together, the iSpot-D study offers this unique opportunity to explore these markers like anxiety and neuroticism across this wide range of data modalities, with the goal to translate these findings into healthcare practice that will save time, effort, cost, and ultimately, and most importantly, patient suffering. So now I'd like to hand it over to Associate Professor Mayuresh, the co-director of the Brain Dynamics Centre.
Thank you, Taylor. Let me just see if I can. All right, can you all see that screen? Thumbs up. Great, excellent. So thank you all for attending this session, and thank you particularly Shukri for coming out and sharing your experience with depression. I think it's really valuable to have people like you to come and talk about your experience with depression. My part today is to talk a bit about bipolar disorder, which sits on the opposite spectrum from depression. There's a spectrum of mood disorders where depression sits on one end and bipolar disorder sits on the other end. And one of the things I'd like to do with the talk is to give you an idea of some of the tools and techniques which we are developing in our lab, and how these techniques can be used to help with diagnosis of bipolar disorder, and also to guide treatment, to come up with novel treatment interventions for this disorder. Now, before I get into it, I'd like to do an exercise, and a simple exercise where I'm going to show you a picture, and I'd like you to think about how do you feel, or what's the first thought that comes to your mind when you see that picture. Now, just to for those who are scared of dogs, look away. All right, so here's the picture. I'm going to give you 10 seconds. Have a think of what you feel, or what's the first thing that comes to your mind when you look at this picture. All right. So most of us might have felt scared, uneasy, terrified, anxious. These are all common emotions, and we experience them in our daily life. Now I'm going to show you another picture and have you do the same thing again. What's the first thing that comes to your mind when you look at this picture? So this picture is quite contrasting from the earlier picture. You're feeling more relaxed, more happy, peaceful. So as you can tell, both the pictures were quite contrasting. The reason of doing this exercise was while you were looking at these pictures and making these judgments, your brain was on full speed trying to analyze these pictures. So what was exactly happening in the brain? What you can see over here is a circuit. So when you looked at the picture, a part of the brain called the visual cortex, which is located at the back of the brain, that actually was processing the picture. And then it sends signals to two different parts of the brain. This portion of the brain called the amygdala, which is a small structure right in the middle of the brain. And this structure fires when it sees different type of emotion stimuli. So when you saw the picture of the dog, the amygdala was heightened and it started sending signals all around. And the reason for this is because the brain operates in quite a dynamic fashion. It helps you make the decision whether it's a stressful, it's a threatening situation. Do you need to run away from the situation or do you need to stay put? And another part of the brain called the prefrontal cortex over here is what helps to make that decision. It helps to evaluate the threat in that situation. So what it does, it sends a signal back to the amygdala and dampens or calms the amygdala down. So, so when you look at the picture, you actually know it's not a real dog in front of you, but it's just a picture of the dog. And you don't really need to run away, but you can stay put. So the point I'm trying to make is your brain is constantly operating while you're dealing with different types of situations, stressful situations, evaluating different emotions in everyday life. And we've developed techniques and tools to measure this, measure these different connections and different recruitment of these areas using a technique called as functional MRI. So functional MRI is a type of imaging, brain imaging technique where we use these a controlled experiment, a controlled task, where we probe the brain showing different type of stimuli and measure the brain health of these different regions. So how well are these different parts of the brain responding to different stimuli, and how these connections are able to work together to control how you react to those stimuli. So with that preview, let me get to depression and bipolar disorders and mental health. Why is this processing of emotions or how you process these different situations relevant for mental disorders? And this is what we consistently see across a lot of number of mental disorders. That is, most of the individuals with mental disorders have a difficulty in processing and regulating emotions. And this is the core reason why you see symptoms of sadness, feeling of worthlessness, guilt, or a disinterest in things which you previously enjoyed. So how you regulate and you process emotions is a core mechanism behind these symptoms. So our goal was, can these mechanisms help us understand mental disorders? And can they help us to not only diagnose mental disorders, but also help in developing and identifying the right treatment for the right patient using these mechanisms? So just to give you a bit of background about bipolar disorder is a bit different from depression. So in depression, you would normally see individuals who are stuck in low moods, or mainly the lows, whereas bipolar disorder is a constant flux between lows and highs. So that's what characterizes bipolar disorder from depression. Bipolar disorder, like depression, is highly prevalent. It's almost the 6th largest mental disorder, which impacts a lot of Australians. It's one of the top 10 illness which has a significant effect on the health of individuals and society. So with bipolar disorder, one of the main clinical challenges with bipolar disorder is almost 40% of patients with bipolar disorder are misdiagnosed as depression or unipolar disorder. And that's because if you look at how both these disorders progress through the course right from start of illness. In case of depression, there are a lot of low moods, and that low mood stays consistently across the illness. But when you look at bipolar disorder has what's called as bipolar depression, which means that person actually starts in a low mood for a long period of time before they switch into the high mood. And that's when the clinician will actually make a diagnosis of bipolar disorder. So in other words, if you look at the starting phase of bipolar disorder, it's exactly the same clinically as depression. And as a result of which, most patients with bipolar disorder will get diagnosed as depression. Now, the problem with that is the treatments for these two disorders are quite different. So if you give a depression treatment to an individual with bipolar disorder, guess what? They will get pushed into the high states fairly quickly. Their symptoms become worse. So antidepressants are not the right treatments for bipolar disorder. So they become really severe. The course of illness is prolonged and they don't get better. So clinically, it's a huge problem in terms of getting the diagnosis right for individuals with bipolar disorder so that they can get onto the right treatment fairly quickly. And that was the goal of our bipolar project. The goal was to see if we can identify different brain markers, biomarkers that can, by measuring the different types of measurements such as EEGs, brain imaging, genetics, clinical questionnaires, symptom reports, cognition, and to see if any of these markers can help clinicians to make a clear diagnosis of bipolar disorder, can help differentiate bipolar disorder from depression, and so that patients can get on to appropriate treatment a lot earlier. So in this study, we specifically looked at emotion processing, the task which I was telling you about earlier, a control environment of how well individuals process emotions, and to see if the circuitry in the brain associated with emotion processing can help distinguish someone with bipolar disorder from unipolar depression. So in the study, we recruited 70 individuals with bipolar disorders, 70 individuals with unipolar depression, and 70 healthy individuals. And we had them do the functional MRI scan with that task. So the task was a slightly different version of showing them scary pictures. We use what we call as emotion processing task, where we show different types of faces depicting different emotions. And this task has been well validated by a group where when we show these type of pictures, we actually see different parts of the brain reacting to different levels. So for example, when we show them sad face, the reaction is a lot higher in case of amygdala as compared to, say, processing of a happy face or a neutral face. So we had individuals inside the scanner. We had all our patients go through the scanner. They did the task, and then we measured the recruitment of these different brain regions and how the brain regions were connected with each other. So in this slide, what you can see is on the y-axis is the level of recruitment. So higher recruitment versus lower recruitment. The three plots over here are the different types of emotions. So that when they're looking at a sad face, or they're looking at a threatening face, or they're looking at a happy face. And the different bars are the different patient cohorts. So the black is bipolar patients. Grays are the level of activity for depressed patients, and white is level of activity for healthy individuals. And this plot corresponds to connectivity of that brain region with another brain regions. And you can tell that there's quite starking differences between individuals with bipolar disorder from those with depression. And we see that consistently across a number of different emotions. And what's interesting is also the connections of how this region is connected to different parts of the brain. So the brain operates quite in a connected manner. So it's really interesting that the wiring of the brain is also important in distinguishing different types of mental disorders. And what we did was we took all these measures and we combined them into a statistical model to see how well we can use this information to predict if one individual is a bipolar disorder patient or a unipolar depression patient. And we saw almost 82% accuracy using these measures. So this sort of accuracy is really, really good because it can now help or give the clinicians the tools to make this, to have the individual do an MRI scan and then and have some confidence in saying whether this person actually is depressed or they might be more likely to be a bipolar disorder patient, and they can get the right kind of treatment earlier on. So with this study, we are identifying some other promising markers as well. So I talked about emotion processing. Emotion regulation, on the other hand, is a different concept where which more corresponds to changing how we feel in certain situations. So emotion processing is more of you look at these emotions and your brain is just reacting. Whereas in case of regulation, you try to make a judgment or change how you feel. So this ability of how you feel, changing how you feel or regulate emotion is really important. And this also is impaired in both mental disorders, but there's a clear distinction between how individuals with bipolar disorder are different from those with unipolar depression. Another marker which we found is a marker which corresponds to attention. So in terms of how well you can identify novel information. So we've developed tasks where we can look at the attention circuitry of the brain, and this measure can also distinguish between those who have bipolar and depression. So now it's important to know that all these measures are impaired with mental disorders, but these measures are sensitive enough to tease out different types of mental disorders. In terms of future directions, our goal really is to be able to identify the risk for bipolar disorder. And Anthony mentioned earlier that genetics is a high risk for depression. It's also the case for bipolar disorder. Almost 60% having a parent who has a bipolar disorder increases their chances by almost 60%. So our goal is, can we use these markers to identify risk for individuals with bipolar disorder? So we are conducting a project where we are recruiting people who are family members of individuals who have bipolar disorder, who are healthy, and to see if these neural markers can tell us or can be detected in these individuals even before they go on to have bipolar disorder. Now, ultimately, how can we use this information to develop novel treatments? And one way we are looking at it is we've identified these different faulty connections in the brain using a different tasks. Can we use this information to, can we develop techniques that can rewire these faulty connections, can enhance neuroplasticity? So we know that the brain is highly plastic. It has its ability to change. So if we identify these markers as risk markers for those who have mental disorders, can we use these techniques to build that resilience, to improve, to fix these faulty connections even before the start of illness onset? And hopefully that kind of approach can help not only to prevent, but also prolong the start of an onset of a disorder. With that, I'll pass on to Anthony again, who will talk more about some of our projects which are going on in depression. Thank you, Anthony.
Thanks, Mayuresh. Can you allow me to share my screen? Thank you. So as, thanks very much, Mayuresh, and thanks, Taylor. And while I get you to breathe while we think about all the different pieces of information that we've been giving you tonight, I'd just like to say hello to some of the people who've dialed in. We have people who've been supporting us in our research. Richard Alcock is the chair of the Western Sydney Local Health District, and we'll be probably touching on some of the research that you're interested in. Certainly Susanna Bluevol, who is and Leslie Rogan, who both lead some of the local groups, care and consumer groups. Thank you for your support of brain dynamics in our research over the years, as well as many of the others who've dialed in to find out what it is that we're doing. So just coming back to the questions about what we'd like to answer. So, I'm a psychiatrist. I look after young people in the community. I'm lucky to work with an excellent team, the Prevention, Early Intervention and Recovery Service, the peers team that allows me to have both psychological and physical treatments. But when a young person comes to me who's had a significant depression, my treatment is very much based upon the symptoms they present with me. I don't know much about the course because they're often very young and it might be only the first or second time that they've been unwell. And I have to play off what works, what they respond to. Now, I have 15 different antidepressants to choose from. I've got about 3 or 4 different mood stabilizers that could be used. And I have therapists who can provide 5 or 6 distinct different sorts of psychotherapies. And it's very difficult to know what is going to be the mixture of treatments that is going to be right for that young person. And one of the things that we've really been looking at over a number of years is to try and help develop ways of figuring out what treatment can be personalized to what person who's coming to me as a treating clinician for their problem. That would cut down significantly on the duration of the length of time that it takes to get a right treatment, and hopefully would bring treatment resolution, cure, a lot that would occur over a lot briefer period of time, so that people would be able to get better and get back into their lives. So that's what we'd really like to do. We'd like to be able to personalize that. And if we're going to personalize it, we need to understand a couple of different things. We need to understand perhaps some of the biomarkers, how we can integrate the experience that a person has had with their illness into the treatment selection. We need to be able to understand how the symptom profile might select one treatment as against another. And we also need to understand more about the genes that predispose towards illness and affect the way the medication are metabolized and even how they might work. We'll just go over a couple of those things and about what we're trying to do with our research program here at the Brain Dynamics. So both Mayuresh and Taylor have talked about fMRI, magnetic resonance imaging research that we do here. We're actually the first unit in Australia to do fMRI, something that we should be proud of. Biomarker research gives the promise of being able to unlock some of that personalised treatment. Both Mayuresh and Taylor talked about a network of connections within the brain. And that's one of the big differences between mental health and neurology. My neurology colleagues look after people with strokes or with Parkinson's disease or other illnesses. They're often illnesses that are localized. There's a spot that is the problem. Mental illness is different. It's a network. So if you think back to both Taylor's and Mayuresh's diagrams, there was this network across the brain that was going wrong for people with these different disorders, and trying to identify that network and then influence that network, increase its activity or decrease its activity is what we want to be able to do. So individual people might be experiencing depression, but different parts of that network will be the problem for that person. Thinking about imaging that network and then influencing it with things like biofeedback. It's one of the things, neurofeedback is one of the things that we'd like to do. We'd also like to use the EEG, the changes in the brainwave activity, to identify patterns which can predict response. And we are working with an industry partner to try and develop those sort of biomarkers to predict which medication would be useful. And in fact, we've gone some way in the iSpot study to identify markers in EEG band activity which can be used to help choose which medication might be useful for an individual. That's at the beginning stages. We've got 15 or 16 different medications. We need to understand the profile of a good number of those different medications. Genes. A lot of illness, a lot of health for that matter, is to do with genes and your inheritance. That's so for depression as well. And it affects health in a number of different ways. Firstly, all the medications that I might prescribe and that people with an illness might take, most of them are metabolized. They're processed by the body in the liver. And that metabolism is quite complicated and is very much governed by a range of different genes called the cytochrome, which control a system called the cytochrome P450 system. Now, if you have an overactive system in one particular area, you'll metabolize, you'll chew through the medication much more quickly, and it won't be effective for you. And the medication won't work because of your genetic profile. Similarly, the genes are also affecting the way that the medication has its effect. So one of the things that we know is that people get better from illnesses like depression when their connectivity in certain parts of the brain increases. That's under the control of another gene, a series of genes, but one important one in particular called brain-derived neuroattractive factor, BDNF. Understanding how variations in that gene interact with different medications will mean that we'll be better able to choose particular genes that will help that healing growth within the brain. It used to be thought that brains were pretty much set once you reach the age of 15 or 16. We now know that lots of things about the brain are plastic. Neuroplasticity is really important in both getting better, but also in underlying some of the illnesses like psychoses that we're very interested in. So brain change and being able to track that is really important part of what we're able to do, and also a very important part of what the new techniques and methodologies like MRI allow us to do. So we're also going to be looking at a number of other different parts of how people bring their experience to us. So Shukri was mentioning how his thinking processes, his concentration, his memory was affected very much by the illness. Taylor presented how we've been able to track how cognition, verbal memory, was associated very much with recovery. This gives us another way of treating people. Using things called cognitive remediation, we can help focus on that and help people improve their cognition, but also we need to be able to track it and measure it. And that's one of the things we're interested in. Sleep is really elemental to good health. So sleep goes out the window with depression and anxiety, and certainly with bipolar disorder at times. So being able to use some of the sleep-giving properties of some of the new antidepressants is a very sensible thing to use with treatment. But being able to track sleep using digital health, Fitbits, things like that, are some of the other parts of the research that we're doing here at Brain Dynamics. And understanding the effects of both early life stress and later life trauma is also important. We all respond to that in a different way, and treatments for that, be it psychotherapy, like treatment trials we run for anxiety and post-traumatic stress disorder, or understanding the effects of very early life stress is elemental to understanding the personal life course of somebody with depression, and then shaping the treatment that we have to best help those people. So you can see if we look around from biomarkers to the experience of illness, to the genes underlying illness and the metabolism of medication, and the symptom profile, that basic phenotype of illness that people present with. We're trying to bring all these different pieces together so that we can help shape it for the individual. Now, we had a number of, when people were registering for the event, there were a number of questions that were given to us by people who have registered. And we had a couple of them. Yeah, having a large, we have about 50 people on the Zoom call. Having questions going backwards and forwards is actually quite a difficult thing to organise. And so there were a number of questions that came in. Often they were of a similar nature. And so the panel, Taylor, Mayuresh and I thought that it might be a good time to perhaps go through a couple of these different questions. And if we're pretty much out of time at the moment, we'll just quickly see if we can go through these for you. And so COVID-19 is on everybody's lips. And so one of the questions was what impact has COVID-19 had on the prevalence of anxiety and depression? And I'm not actually able to answer that as I've been working with a lot of young people with COVID-19. I've also have some colleagues who've been working looking at the overall figures in New South Wales. And sorry, the cleaner is coming along the corridor here, shaking doors. So we'll just getting control of that. So COVID-19 has certainly had a significant effect upon anxiety and depression, but it's had a greatly enlarged effect actually in young people. So it's particularly people under the age of 25 in the New South Wales state figures that have had difficulties with an increase in presentations to the emergency department with anxiety and depression. And older people have certainly been stressed. I think many of us have been stressed by it, but it's really having its impact in these younger people who have had so many of those social networking opportunities removed from them. And that's what we're seeing at the moment. Now, for the next question, I think I'll pass this on to Taylor. So, Taylor, if you'd like to have go at this particular question.
Yes, thanks, Anthony. So this is given the diversity and experience for people with depression, do you think that the blanket approach to treatment is being challenged as much as it should? So the diversity is not only in the experience of people with depression, but also in the way that we diagnose it. So depression is diagnosed using the DSM, or the Diagnostic and Statistic Manual for Mental Disorders. And in that manual, it requires at least 5 of 9 different symptom criteria to be met. This results in over 200 different ways that someone can meet the criteria for major depression. It also means that it's possible for 2 people to be diagnosed with depression to have 0 overlapping symptoms. So what we end up with is this very diverse group of people, even though the symptom criteria are connected and kind of hang together in this clinical diagnosis. As for whether it's being challenged as much as it should, this is kind of where the field of personalized medicine or precision medicine is trying to make ground. So most people would probably agree that the blanket treatments that we have are less than optimal, which is why we end up with statistics like half the people don't respond to their first antidepressants. But as Anthony discussed before, by combining different markers across these kind of different data modalities to predict treatment outcome, these blanket treatments would be able to become more personalized and more effective. The other challenge, the other thing that can kind of help this is the introduction of more advanced techniques like machine learning and artificial intelligence, which can assist in this precision medicine and identifying, these more specific treatment types. And so I'll pass it over now to Mayuresh for does technology have the potential? Oh, sorry, I'll pass it to Anthony to what impact does COVID-19, what technology has the potential to enhance patient engagement?
Thanks, Taylor. So I've got a particular interest in this because of one of the other research projects we've got here called Unwired, which we have running with the help of Western Sydney Local Health District in particular, and the Balmades Foundation. And that's allowing us to use technology, a Fitbit like device called an Embrace, to measure people's activity and their how stressed they are, their electrodermal activity. And we're integrating that with our care for young people with mental illness to see if we can get in first, we can get in before people have a relapse. And it's in this sort of way that technology really can help engage people. Lots of people have apps, lots of people have measured their steps, lots of people are measuring their sleep. And all of these things, if you actually do them, if you're encouraged to do them and given some structure, can really be a useful addition to enhancing a patient's experience, a person's experience. Some of you will probably have met with your GP or your doctor or your specialist over telehealth during COVID, these COVID times. And so you really are being given a crash course in how technology has the potential to help people. So we spend a lot of time bemoaning Facebook and the effects of social media, but we can also harness those platforms as a way of helping us understand people's lives, people's activities, and helping them get a bit more control over their symptoms. So this is a rapidly evolving field, something that I'm very interested in. I'm very thankful that we've been able to have the support of the local health district and Balmades in doing that. And Mayuresh, I think you are looking at this very important question about resilience.
Yes, thanks, Anthony. I think the question is, how important is it for parents to teach children resilience as it relates to improving mental health outcomes? I think this is a really great question because it comes back to what can we do to prevent mental disorders or even prolong mental disorders. Now, and especially children. Now, if you look at how things have changed over the last 5 decades, the prevalence of mental disorders has increased quite a bit. And tying it back to what Anthony was saying in terms of technology, I mean, we see how technology has changed how we interact with individuals, how we interact with the society. A lot of children spend a lot of time in their rooms or on their phones, and they're quite cut off from the outside world. They're not, and what that does, it impairs their ability to form positive relationships, have friends, just go out and play. So, I mean, I think that's where parents can really come into play here. Helping children, giving them the skills to build this positive psychology, positive resilience by teaching them how to make friends, pushing them out to play more, giving them a healthy environment. Eating is another important aspect of it. We know that eating good food, exercise, builds serotonin levels, which are important to prevent some of these mental disorders. And but junk food has an opposite effect. So the kind of nutrition you can have has an impact on your mental health as well. So I think these are all important points, and these are small things, small changes which we can do in our life to help prevent or build resilience towards mental health.
So thanks, Mayuresh. So yes, I just have to echo it. Resilience is about being with people, learning how to link with people, being taught about life, having a good education, looking after yourself physically. So they're very important, all very important basic things. Look, you've joined us now for over an hour, and I'd like to thank you for being our audience. It's always great to be able to present things. We'll have to work on some of the interactivity, I would have to confess, but it's really encouraging as researchers to see a large audience out there wanting to learn about the research that we've been doing. This builds upon some of the presentations we've done from last year and during Bipolar Disorder Week. And so we'd really like to thank you as the audience for coming along, and to the many people who, like Shukri, who have volunteered to take part in our research, because without people volunteering to take part in our research, we're not able to do any of it, of course. We have our funding from NHMRC and ARC as well, and the Medical Research Futures Fund, as well as our other philanthropic sources, and that really reminds me that the Westmead Institute is quite a new medical research institute. We do not have the network of philanthropists that some of the older medical research institutes perhaps do. And so if you are at all interested by what we've talked about today, or some of the other research that you can see on the Westmead Institute website, please think about making a donation, however small, or getting in contact with our philanthropy team, which you can contact through the website. So look, with that, I'd like to thank my fellow speakers, particularly Shukri Ahmed, for coming in and giving us an idea about his story. Taylor Braund, one of our PhD students, and Mayuresh Korgaonkar, who's the director of Brain Dynamics Centre. And thank you all very much for taking part in this webinar. There will be another one next week, and the details of that will be on the website. But thank you very much for attending, and with that, I'll bring the webinar to a close. Good night.